Going to be going through the lesson for 7.5, Reflections and Lines of Symmetry. Our goal is to demonstrate an understanding of line symmetry and rotation symmetry. So this is going to go back a little bit, a few years ago really, to grade 6 when we were looking at rotations, reflections, and translations. We're going to be working with those same words, that same terminology, but we're just going to look at it in a different point of view and not necessarily all the time on a Cartesian plane. So when congruent copies of a polygon are used to cover a flat surface with no overlaps or gaps, a tessellation is created. And some tessellations have line symmetry. So really what we're looking at is we're going to be looking at a tessellation, which is just an image that has been repeated in different ways. And we're going to be asking if there is any symmetry. Symmetry is like, is there a reflection image? Can I cut it in half and the lines match up anywhere? So identify the lines of symmetry in this tessellation. So if I'm looking at this one right here, I know that because it is a square, I could cut it in the middle, and if I cut it in the middle here and actually folded it, I know that these two corners would meet and these two corners would meet, which means that it has a line of symmetry that's right through the center. Okay, I also know, once again, because it's a large square, that I can cut it horizontally because these two corners could match up and the images would also still perfectly align. Okay. As it is a square, I can also look to see if there is any diagonal lines. So if I were to cut it across the center in the middle, and maybe it'd be better if I just took like a ruler, and you can see that on both sides of the image, it is exactly the same image. So I know that I can also cut it diagonally this way and this way. Okay, so a line of symmetry must pass through the center of the design, and unfortunately, you guys don't have any mirrors to kind of check, but you can kind of do a trick like I did where I just took a ruler, or you can take a straight page and just kind of look. Does both sides of it look the same? So in the end, I can say that this tessellation does have 4 lines of symmetry. It has 1 vertical, 1 horizontal, and 2 diagonal lines. So if we look at this check, draw the lines of symmetry in each tessellation. So again, you unfortunately do not have a mirror, so you're just going to be using a method of your choice, whether it's a paper, whether it's your pen, pencil. How can I cut this shape so that it looks the same? So if I were to cut this one straight across the center, that would actually work. So I would say that this, through the center of the object, would be a horizontal line of symmetry. Now, if I cut it here, it wouldn't work because it's not the same distance on both sides of my pencil or ruler. And if I choose to look at it this way, to make it a little bit easier for you. So I can only cut it once horizontally. So is there a horizontal line of symmetry? Yes, there is one. Is there a vertical line of symmetry? So can I cut it the other way? So if I cut it over here, I can see that it's not the same thing on both sides of it. But if I went and crossed the center of my image, and it's a little bit harder to do with this ruler that's not straight, you can see that if I cut it exactly down the center, both sides are the same. So I could say that I do still have 1 vertical line of symmetry. Now, because this is a square, I can check to see if there's a diagonal line of symmetry, and there is. There's one this way, and there's also one that would go diagonally the other way. So vertical or diagonal lines of symmetry, there are 2. And please also remember that the line of symmetry should always be going through the center of the design. So that's kind of your like hint to help you out. Is there vertical line of symmetry in this image? So that means vertical up and down. Is there a place? So we know it should be going through the center of the object. There is my center. If I were to draw a line that crosses it, is it a vertical line of symmetry? We would say yes, there is one. Is there a horizontal line of symmetry? So if I were to cut it through the middle, straight across. Is it the same on the top and the bottom? Yes, there is. So I would say there is one horizontal line of symmetry. And is there any diagonal lines? So if I were to cut it this way, and picture folding it. If I were to fold it, does this corner match up with this corner if I fold it along where the ruler is? And you might actually need to physically bend it to see if it works. But it does not actually match. This corner would actually be somewhat over here and not way over here. So are there any diagonal lines of symmetry? I'm going to say no, there's not. Or I could have just put a 0 to show that there is none. Okay, then draw the lines of symmetry. So there was one that was vertical and there is one that was horizontal. Which polygon is a reflection of the shaded polygon? So now we're going to be working again, going back to some old terminology. Reflection. That means, is it the same object just flipped over a line? So I want to know which one or two would be a reflection of the shaded image. So again, we do not have a mirror, so you might actually be physically folding your paper or doing a method like this. The polygon is to the, so we're looking at polygon 1. So polygon 1 is to the left. Okay, so it's over to the side of the shaded polygon. So to see if it is a reflection, we would need to look at a vertical line. So that's how I would be crossing it over. So I would try a vertical line of reflection. The polygon is or is not a reflection of the image. So if I'm looking at it and if I were to fold it across that line, is it the same shape? No, right? It would have had to have been long on the bottom and not at the top. It's like rotated and not actually reflected. So the polygon is not a reflection image of the shaded polygon. So if I'm going to do the same thing with polygon 2, this time the polygon is under the shaded polygon. So to figure out if it works, I'm going to need to draw a horizontal line of reflection. And if I were to draw this line here, does that image flip on itself? Would it match? Same distance from that line on both sides? I would be able to say yes. So the polygon is a reflection image of the shaded polygon. And if the polygon is a reflection image, please draw the line of reflection. So the line of reflection can be found between the two shapes. So here's another example of working with linear relationships and reflections, but this one is going back to using the Cartesian plane. So if I want to reflect the quadrilateral means four-sided shape, in the line of reflection to make a larger shape. So point E on the line of reflection is right here. So it is on the line of reflection. So if I were to do a reflection of it, the new image would still be, so my E1, we put the little ones to show it's a new image, would still be on the line of reflection. Point F, which is right here, is 2 squares to the left of the line. So to find the new F, I would need to do 2 squares to the right of the line. Okay, and again, new image would have that little tick to show that it is a new image. Point G is 1 square to the left. So our reflection image would then have to be 1 square to the right. Point H would be right here, is once again on the line of reflection. So my reflection image of H1 should also be on the line of reflection. So it says plot the points and join the points to complete the larger shape. So I can see that both sides of my shape is the same. It makes one full shape. And then it has a place here for to actually put in the coordinates or ordered pairs. So E is at 3, 5. So E1 is also at 3, 5. F was at 1 and 3, and F1 is going to be at 5 and 3. G was actually at 2 and 1, so G1 is going to be at 4 and 1. And H, which was at 3 and 1, is still going to stay at 3 and 1. Okay, so just a couple more to practice, not on the Cartesian plane, but just draw the lines of symmetry in each tessellation. So where would you be able to cut this shape and it be the same on both sides? Again, you may need to be kind of moving things around to see what you can do. I would say that there is one horizontal line that cuts it through the center. I would say that there is one vertical line that cuts it going up. But if I were to ever try to do it this way, the points don't match up in the same way. So I would say that there is no diagonal lines, that there is just 2 lines in total. If I am looking at my second shape, if I tried to cut it this way and fold it over, I should see that it's not going to work because this one has ends sticking out in the center, and if I flipped it, it would not be in the same place. So I would say that there is no horizontal line. I can try a vertical line. So if I were to cut or fold it over the center, the 2 points stick out at the top. I have some 2 a little bit further away at the bottom. I would say that there is a vertical line that cuts through it. And then I should always be checking if there's any diagonals. And as you can see, they are not shaped the same on opposite corners, so I would not say that there is any. So in this shape, there is actually only one line of symmetry. Now, when you are working, it is important to note that it has to match up identically, both where the shapes are, but also colors. So I don't have colors in any of these examples, and in your textbook, there is going to be some questions that have colors. And if the colors do not match, then it does not work. So if you just had even like a square like this, and this was black, and this is black, but these two are white, okay, I can say that I cannot do a vertical line because the black would fold on the black and they don't match each other. Same as I would not be able to have done a horizontal line because, again, my colors were not matched where I would fold it. However, in this case, I could have done a diagonal line still in both directions because the colors would match. So please pay attention to things like color or details because it does have an impact on whether or not it works. So these are some questions in your textbook for you to give a try. If you have any concerns or questions, please make sure you're sending me an email, and I look forward to seeing you again in class. Have a great day.